If you want Unity 3D, CryEngine, or Unreal Engine tutorials, like, comment, or subscribe for more. This is the Rising Phoenix dev Jesco, and today we will continue with our How It's Developed series with episode 3. In this episode, we will be continuing to work on our player class. However, before we begin, I must note that CryEngine 5.5 preview has been released, and after this episode, I will be converting this project to the preview build of the engine. If you haven't already, go check out episode 1 and episode 2, as they have very important code you need in order to make everything work later on. So let's sit back, relax, and get started with episode 3 of our How It's Developed No Man's Sky multi-tool tutorial in CryEngine. Let's begin by opening up the SLN file in Visual Studio, navigating to the player class, and let's begin by creating our next method underneath the initialize input method that we left off with in the previous episode. This next method will be private void prepare rigid body. This method will check to see if we have a physics entity enabled and then activate the physics. Var physics entity is set to entity.physics. Entity.physics is the representation of this specific entity, the player in the physics engine. If physics entity is equal to null, then we return. The return keyword terminates the execution of the method. We will now call the physicalize method, which we are creating next. So let's go ahead and create our private void physicalize method. Create a variable called var parameters and set it to be new living physicalize params. Living physicalize params is a special entity type for representing the player that can move and interact with the game world. We create another variable called player dynamics, and that is set to parameters.playerDynamics. These parameters define the player's dynamics, which we will use next. Write playerDynamics.mass and set it to be 90 float. This sets the player's mass in kilograms to be 90. We now put it all together with entity.physics.physicalize and put parameters in the method's parameter around brackets. We can now create our methods for onMove for forward, back, right, and left. These are pretty much the exact same thing with very minor changes. All of these methods should be private void method types with the parameters of string name, input state, and float value. OnMove forward and OnMove backward are first. Create an if statement with the state is equal to input state.pressed. Inside of it, underscore movement.y is set to 1.0 float. Create an else if statement with the state is equal to input state.released. Inside of that, create an if statement with underscore movement.y is greater than 0.0 float. Inside is underscore movement.y is set to 0.0 float. This ensures that the player movement will be stopped if the player is still moving forwards. For onMove backwards, the first if statement should have the underscore movement.y be set to negative 1.0 float. The else if statement is the exact same as onMove forward. Now we can move on to onMove right and onMove left. OnMove left should have underscore movement.x instead of underscore movement.y with the value of negative 1.0 float, with the else if statement being the same as onMove forward with an x value instead of a y value. OnMove right will be the same as onMove left with the value being 1.0 float. The else if is the exact same as onMove left. With onMove mouse x, we will create an if statement with the state is not equal to input state.changed, then we return. This will ignore any other state than changed is received. Underscore rotation movement.x adds a value to whatever the value of underscore rotation movement.x has, which is what we set in the parameters of the onMove mouse x and onMove mouse y methods. OnMove mouse y has a slight variant to onMove mouse x. We will still have the first if statement, but we add another if statement to it, and we are only checking that inverse vertical rotation boolean value that we set in the fields at the top of the class. If inverse vertical rotation, set the value to be negative value. Now, under that if statement, we set the underscore rotation movement.y to add value to whatever the value of underscore rotation movement.y is. We need an update method for all of our movement, so let's create that next. We will call this method private void update movement with the parameters of float, which is frame time. The first thing we do is create a variable called entity and set it to be entity. We now need to create a variable called physical entity and set that to be entity.physics. Some of you may be wondering what the entity is. Entity is a wrapper for the iEntity class for CryEngine. It provides properties and wraps functions for easier access to iEntity functions. We now create an if statement for if physical entity is equal to null, then we return and break out of this method. Create a variable called movement and set it to be a new vector3 with the parameters of _movement. And if we remember, we set _vector2 movement to be a private vector2 which is set to vector2.0. Next up, we need to transform the movement to camera space. To do this, we need to call that movement variable and set it to be camera.transformDirection with the parameters of movement. We now have a problem that we need to address. Because the camera space is a vector3, we need to make sure we flatten the z-axis to remove the height value. Otherwise, the movement would point up or down unexpectedly. To do this, we set movement.z to be set to 0.0 float. The next thing to do is to set movement to be movement.normalized. Normalizing vector means that the vector is returned with a magnitude of 1 but keeps the same direction. However, if the vector is too small to be normalized, a 0 vector will be returned. The last thing we need to do inside of this method is to create an if statement. If movement.length squared is greater than 0.0 float. The easiest way to explain this is that we are calculating the length of the vector squared. It does this by returning the value of _x times _x plus _y times _y plus _z times _z. Inside of the if statement, we set movement to be times equal move speed times frame time. So what we are effectively doing is multiplying our current movement times the move speed times frame time. This is done to keep the movement consistent across different machines. Finally, we set physicalEntity.move with the parameters of movement. PhysicalEntity.move makes sure that the physics engine can ensure that collisions are taken into account when moving the entity. This entity will only move as far as it can in that direction, and if any obstacles are in the way, the entity will correctly interact with the obstacle. Now we need to create our onInitialize method. We will write protected override void onInitialize.
Newbie note. OnInitialize is part of an abstract class, and in order to call the base virtual method, we have to override it. End newbie note.
And we don't actually have to override the code that is implemented, so we just call base.onInitialize. And this finishes this method. We have 3 methods left to write, and then we are completely finished with this class. Kill me now. The first of the last 3 is our onUpdate method, which is protected override void onUpdate with the parameter of float frame time. We don't need to override the base implementation of onUpdate, so we can type base.onUpdate with the parameter of frame time. We now create a variable called camera rotation. Set camera rotation to be _player_view is equal to null with the conditional operator. Camera.rotation :_player_view.update_view with the parameters of frame time, _rotation movement. Alright, time to explain this. We are doing something called an inline if statement. We first need to understand how an inline if statement is supposed to be read. It starts with the condition, followed by the question mark, then the first expression, second expression. That means our condition is if _player_view is equal to null. Then nothing happens. Our first expression is camera.rotation, and our second expression is _player_view.update_view with the parameters of frame time, _rotation movement. We set _rotation movement to be vector2.0. This is done to initialize the rotation movement at a 0 vector value. Lastly, we call update movement with the parameter of frame time. We do this to make sure our movement updates with the update method. The second to last method is our onGameplayStart method. This one is also a protected override void, and it is called onGameplayStart.
Obviously.
The first thing we want to do is type _player_view is set to new player view with the parameter of this. We do this to make sure the player view is set to this specific entity. We call base.onGameplayStart because we want the base implementation to also be in effect. Now, we can call initialize input and prepare rigid body respectively. We want both of these methods to start as soon as the gameplay does. Our last method is onEditor game mode change.
And as you guessed it,
It is a protected override void called onEditor game mode change with the parameters of bool enter game. The first thing we do is call base.onEditor game mode change with the parameters of enter game.
Which again,
Because we don't want to override the base implementation entirely, just add a bit more to it. The last thing we need to do is an if statement. If not enter game. Inside of this if statement, we have two methods. The first one is _player_view .deinitialize. The question mark here marks _player_view as a nullable type. This is important because being able to mark it nullable means we can say that we want it to be set to null. Which brings us to our final call of _player_view is set to null. Whew. That was a hell of a lot of talking, and I need some tea to wet my whistle. With that, this concludes episode 3 of our How It's Developed series, and in the next episode, we will finish the implementation of our player view class and also convert the project from CryEngine 5.4 to CryEngine 5.5 preview build. This has been the Rising Phoenix Dev Jesco, and remember, tutorials are only designed to give you basic information on how to do something, and should not be used as a crutch for all of your game development and programming learning. Also, if you need to implement a fresh product